In this video, we're going to be building a side-scrolling camera system. Our camera system will be able to switch between different methods of scrolling, which will give us a lot of flexibility when we're building our games. In concept, a game camera doesn't work too differently from a camera in real life. Cameras take a large setting and focus in on a smaller portion, usually pointing to one object as the particular focus. That particular focus in a side-scroller is usually the player character. We'll denote the player's position relative to the frame of view as their offset, and we'll need to keep track of this offset value in both the X and Y directions. If our game world is our setting, then our game window or screen will act as our camera. By using those offset values, we'll be able to move our screen and focus it at the appropriate position. We're going to hold our camera system in its own file called camera.py, so porting it over to your game or project should be really simple. I'll be using the little game I made in my last tutorial for demonstration purposes, so if you want to follow along with me, feel free to download it from my GitHub. With all that out of the way, let's open up camera.py and get started. We're going to start by importing Pygame. Then I'm also going to take the vector2 class from pygame.math. This will make it easy for us to handle X and Y coordinates. Now let's go ahead and declare a camera class with an init function. We're going to need access to our player variables, so I'm going to go ahead and make a reference to our player here. If you have other ways of accessing player variables such as with a game object, feel free to use that too. Now let's go ahead and use that vector2 class. Our first vector will be for those offset values I had mentioned earlier. This offset value is what we're going to use to frame our camera in the correct position. Since our screen works in pixels, the self.offset needs to be an integer. So if your game doesn't have integer movement, you're going to lose precision in your calculations. So let's go ahead and make another variable, offset float, which will be another vector that will store the precise position of our offset. Last thing we're going to do here, I'm going to make some variables to keep track of my screen's width and height for convenience, and then another vector called self.constant. I'll be explaining what we use this vector for a little later, so if you're working on your own game, feel free to just set it to 0, 0 for now. To finish off the camera class, we're going to declare two functions, setMethod and scroll. Let's go ahead and take a look at a diagram to see how exactly we're going to use these. Earlier I had mentioned that there's actually different ways we can handle the camera. Which method to use might depend on the context of your game. So on one level, you might want to follow the player, while on another level, maybe the screen can move on its own and it's up to the player to keep up. So our camera needs to be able to switch between these three methods so it can go into each of them and call the appropriate scroll function. To achieve this behavior, we're going to use a little trick that involves inheritance. We're going to create a class called scrollMethod, and this is going to be what's known as an abstract class. You can think of it as sort of like a blank template. All of our scrolling methods are going to inherit from this abstract class scrollMethod, which means that we can treat them as if they were all the same. So when our game is running, Python will go ahead and fill in this blank template with whatever method we need. If you've ever looked into design patterns, you might recognize this as the strategy pattern. So if we go back to our code, setMethod is going to be the function that actually picks which method we're using, whether it be auto, follow, or border. And then the scroll function will call on that scroll method to perform the necessary calculations. For this system to work, we're going to need to make classes for each of our methods. Let's start by importing the ABC, or abstract base class. This is what will let us create our blank template. Now let's go ahead and declare a class that we'll call camScroll. CamScroll is going to be what all of our other classes inherit from. The init function is going to need a reference to both the camera and the player, and that way all of our methods that inherit will have them too. Since all of our methods are going to have a scroll function, let's go ahead and put one right here. Except this time we're going to add this abstract method decorator onto it. What this will do is if this spot right here isn't filled, it'll tell Python that something went wrong. Now let's go ahead and make our first class to handle camera behavior. What this will do is have our camera follow the player around. So we'll go ahead and call it follow. Follow is going to inherit from camScroll, so we can go ahead and just use that init function. Now let's write the scroll function. This is the formula you're going to use if you want the camera to follow the player. It looks a little confusing, but I'll explain it. For the sake of demonstration, let's say the stick guy is our player and this box is our camera. A whole iteration of our game loop happens and our player ends up moving maybe 5 pixels. Let's take the difference between the player's current position and the camera's current position. And then let's go ahead and add that difference back onto the camera's position. This will update the camera's position right back to the player. So if we keep things the way they are, the player will always appear at the left side of the screen because the camera will just keep on chasing them. But if we pull the screen back by some constant c, then we can control exactly where the player will appear. So in this case, if I subtract half the screen size from the offset, then the player will always appear at the middle of the screen. So if we go back to our code, this is exactly what's happening in this little formula right here. I'm taking the difference so the camera can go ahead and chase the player, but then I'm also adding this constant, which happens to be a negative number, to put the player exactly where I want them in frame. We can go ahead and do the same thing for our y variable, and it'll work just the same way. Last thing we want to do here is cast these offset float values into integer values. We want to keep our precision, so we'll go ahead and store them in a different vector. But because we're using pixels as our unit, we need to make sure that when we actually move the camera, we put in an integer. That should be everything for our follow method. Now let's go ahead and make a new class, which we're going to call border. Border is going to be very similar to follow. It's going to follow the player wherever they go. The difference is that if border reaches a certain threshold, the camera will stop scrolling and it'll just stop to a halt. So we can start by just copy and pasting everything that we currently have from the follow class. We're just going to need to make a small adjustment at the end. To stop the camera from scrolling in the left direction, we're going to use the max function. Our first argument is going to be some predefined border that we don't want the player to see past. This will be an x coordinate. And then our second argument is going to be the offset or position of our camera. This will stop the camera from being able to scroll past the border that we set for it. To handle the right side, we're going to do something very similar, except this time instead of using the max function, we're using the min function. Camera.offset.x technically applies to the screen's left side, so if we're working with the right side, we need to subtract the screen's length from our right border, and this will normalize things for us. That should be everything we need for our border class. So now we can move on to the final scroll method we'll be implementing in this tutorial. And this is going to be the auto scroll method. Here, the screen's going to move independently of the player. So you can think of those endless runner type games or those Mario levels where the screen moves and it's just up to you to keep up. This one's actually really simple to implement. We're just going to increment the offset by some value. In this case I picked 1, so it's going to move the screen 1 pixel every frame. Incrementing by a positive number will make the screen move right, and incrementing by a negative number will make the screen move left. And then you could go ahead and add some player logic so that when the screen catches up with the player, maybe the screen carries the player with them. And that should be everything we're going to need for our camera class. Like I said, there's so many different ways you could handle the camera, so feel free to play around with it however you want. Let's go ahead and head into our main game loop so we can see how we can put this camera into action. We'll start by importing everything we just made in our camera.py file. And now let's go ahead and instantiate an object for each of the classes that we just made. So we should have a camera, follow, border, and auto object. We're also going to use the set method function to set our camera's default method to follow. I'm going to go ahead and scroll down into my event loop, and I'm going to add some keys that will let me switch between the methods. So we're going to add some else if statements, and if I press 1, 2, or 3, I'll be able to switch between the follow, auto, and border methods of scrolling. Let's go down to where we update our player. And this is what we're going to want to call camera.scroll. So whatever method is currently picked, the associated scroll function is going to be performed here. And now we're on to the final step. Inside our blitz statements, we need to subtract the camera's offset from anything that's going to be moving in our game. You'll want to make sure both the x and y coordinates are adjusted with that offset correctly. This modification to the blitz statement is what actually creates the illusion of our camera moving back and forth. That should be everything, so let's go ahead and run our game so we can see our resulting camera system at play. And here's the resulting window. Now that we're in the game, let's go ahead and test each of our camera functions. So, if I move around, we can see that the follow function is working just fine. If I press 2, the camera starts to scroll to the right, and it moves independently of me no matter what I do. Now right here I have a little border, so if I press 3, I shouldn't be able to see past it. If I press 3, and the camera stops, right where the border is. If I go left, the camera keeps moving. And if I press 1 again, we can see that the border is still right there, and I'm able to see past it again. So everything's working as intended, and we now have a nice flexible camera system for our game. And that'll be the end of this tutorial. Hopefully you were able to follow along, and you'll be able to apply that camera class to whatever project you're working on right now. All the code for this video will be linked down below, so if you fell behind at any point, feel free to take a look at it there and catch up. I really appreciate you watching this tutorial and sticking around. If you enjoyed it, consider subscribing. If you have any questions or comments, feel free to post them down below, and I promise I'll take a look at them. I hope you're able to stay safe and take care.